Hey everyone, raise your hands if you have ever looked at chemistry past paper and felt your brain freeze with when you see question about atomic orbital, quantum number, and mass spectrometer. Yes, I thought so. You are not alone. This topic feels abstract and complicated, but what if I told you that JAMB and WAEC has the same core concepts every single year? In this video, we are going to demolish 7 of their favorite questions in atomic theory. I am not just going to give you the answers, I am going to give you the simple step-by-step thinking process so I can solve any variation they throw at you. Let's turn this from your weakest topic into your strongest guarantee mark. Stick around because by the end of this video, you will be solving this question in your sleep. Now, let's look at what the first 2 sets of questions. So let's look at question 1. Which of the following species determine the chemical property of an atom? Is it electron? Is it nucleus? Is it neutron? Is it nucleus or proton? Now, when we talk about chemical property deals with how atom bonds or react with other atom to form a bond. To form a bond, and bond means what? Molecule. And the part of the atom it's used is the electron. So it is the electrons that determine the chemical property of an atom, because an atom can either lose or gain electron to form a bond. So electron is the answer. When you see the kind of question, electron is the answer. But now look at what nucleus. Nucleus do not determine the physical property. Why? It is buried down the nucleus. It's buried down inside the atom. Remember, the mass, the nucleus of the atom contains the proton and the neutron itself, right? So the neutron do not determine anything. It only affects the mass of the atom. Do you understand? Or determine the mass of the atom. It also tells about what the isotopy, right? It also affects the isotopy of the atom. You are going to look at that. Now, for C, nucleus. For C, here we have what? Nucleus. Nucleus don't have any effect because nucleus is buried down inside the atom. So now we talk about the part in which atom use in chemical bond. We are talking about the atomos shell. Atomos shell. Proton determine the atomic number of the atom. Proton number is just determine the position of the atom in the electronic configuration. So the answer is electron. Electron determine the chemical property of an atom. Do you understand? So look at our question 2. Pauli exclusion principle is related to what? Therefore, what is Pauli exclusion principle? Pauli exclusion principle states that no 2 electrons in an atom can have their 4 quantum number the same. No 2 electrons in an atom can have their 4 quantum number the same. So Pauli exclusion principle is talking about quantum number. Do you understand? Quantum number of electrons. So D is the answer. D is the answer. So you can see how easy this question is. I have done a complete video on this aspect here, but this video is only available to our private students. We are talking about atomic structure, quantum number, and questions like this. They do ask me that because you need to understand the fundamental. That is why if you are writing JAMB in 2026, I have not joined our private class, you know that you are missing a lot. We have 3 more blueprints that you are using. You get? So for those of you who want to join our private class, we have our general class. We also have our private class. Now to join our general class, there's a link at the description that will take to join our general class, right? That general class we only learn once a week, but in our private class we learn every single day. Saturday is always our mock test for the week. Just that. So if you want to join the class is just 29,000 for the 3 months. Cover every single thing. So let's look at what question 3 and question 4. Our question 3 and question 4. Question 3 and question 4, they are quite confusing. So please pay close attention. Atomic orbital. A. The circular path through which electrons revolve around the nucleus. B. This should be B. Region around nucleus where electrons are mostly likely to be found. C. The path around nucleus through which electrons move. Then D. The path around nucleus which proton move. Now, let me explain. When you look at what the concept of atom, if you look at the structure of the atom have two main parts. We have what we call the shell, and we have what we call nucleus. Right? Now, the nucleus contains two fundamental parts, which are the proton and what are the neutron. Why the electron here? Look at the electron here. Right? Now, they are talking about the shell. The shell, you also know what as orbital. Orbital is where electrons are located or electrons are likely to be found. In that orbital, electrons revolve around the nucleus. So you say that it might be confusing because here we say the circular path through which electrons revolve around the nucleus, the region around the nucleus where electrons are most likely to be found. These two are likely to be answered, but which one is the correct answer? The most accurate answer is what? Orbital is the region in which electrons are likely to be found because orbital is where holds the electron. So the answer is this, not this. So when you see these two options, please take on here because this is what is the most accurate. Because orbital is where electrons are located or is where electrons can be found. Do you understand? So this is what is the answer. Hope you understand. So let's look at what question number 4. Question number 4 is a little bit tricky here. Please make what she say. How many orbitals are contained in an atom with atomic number 13? Now, not a majority of students will fail this question, but please pay attention. In order to get the numbers of one orbital that the atomic number 13 it will contain, therefore you need to write the electronic configuration, right? And to write the electronic configuration for JAMB, WAEC, and secondary school stuff here, you need this one. This is what you need: 1x, 2x, 2p, 3x, 3p, 4x, 3d. This is what you need. Right there. 1x, 2x, 2p, 3x, 3p, 4x, 3d. Please pay close attention. Remember, the x orbital contains only one suborbital. The p orbital contains 3 suborbital. Right? The d orbital contains 5 suborbital. 1, 2, 3, 4, 5. And the f orbital contains 7. 1, 2, 3, 4, 5, 6, 7. Right? So you need to pay close attention to this thing here. Remember, S currently accommodates 6 electrons. Please, if you don't know how to write electric configuration or you don't know quantum number, in my private class, I have a complete video on quantum number, how to understand quantum number, how to write electric configuration. I've done all of those videos. Now, that class is only available for our private students. So if you're a private student, understand that you have done this topic, so this one should not be an issue for you. So now for those of you who want to join our class, now our 3 months class have started. You need to join that class so I can start learning. The class is 29,000 for now till when you write your exam. 29,000 for the first 100 person. So if you're interested to join that class, send me a message so that you start join others who have started learning. Hope you understand. Okay. With this understanding here, S, you know that S can only accommodate what, 2 electrons. S will accommodate 2 electrons. So this guy will only have 2 electrons. P will accommodate 6 what, electrons. 6 electrons. 6 electrons. D will accommodate what, 10 electrons. 10 what, electrons. And F will accommodate what, 14 electrons. 14 what, electrons. So I'll write this place here. Let me write this place. So I'll go. So okay. So now we want to write the electrical configuration of what for this guy here, right? We understand here we have 1s, 2s, 2p, 3s, 3p, 4s, 3d. For the be able to answer this for here, you must first write the electrical configuration. So let's take out 1x, 1x. Remember here we have atomic number of 13, right? How many electrons will come here? Remember s can accommodate only what, 2 electrons. So here we have 2. So 1s2. So out of the 13, I have used what, 2. It's okay. Like I said, please know these things. This one here, know them. 1s, 2s, 2p, 3s, 3p, 4s, 3d. Now they will not ask you question more than this one here. Do you understand? With this one you can do so many things. Now let's look at our 2x. 2x, right? S can be having electron, 2 electrons. So 2 will be here. So out of the 30, I have used 4, right? Next is what? 2p. 2p, right? P will accumulate electrons, 6 electrons. So I'll put 6 here. Calculate everything. Everything is now what? Everything is now what? 10. We still have 3 left because here is 13. So 10 or 13 minus 10, here we still have 3 more electrons. Let's continue. Let's enter here 3x. 3x. And so I accumulate electron, 2 electrons. So here we have 2. So I have 1 left. And what is 1? 3p. 3p1. Please pay close attention. Pay close attention. So if you look at it very well, this guy X only have what? 1 orbital. Like this. So this one is 1x, right? How many electrons do you have here? Here we have 1 and 2. Right? So this will only have 1 orbital. If you look at this one only have 1 orbital. So you have 1 orbital. 1 what? Orbital. If you check the 1 orbital. Here we have 2x, right? Here we have 2x like this. How many orbital I have here? Here we have only 1 what? Orbital. Because S only have 1 orbital, which is this box here. If you look at what? 2p. 2p, which is what? Like this. 1, 2, 3, 4, 5, 6. Right? Here we have 6. What up here? How many orbitals do you have here? 1, 2, 3. Here, the 3 have P have 3 suborbitals. So here we have what? 3. 1, 2, 3. Here we have 3. Let's move to this one here. Here we have. Look at this guy here. This guy only have what? 1. This is that. Now, if you look at this P, 3p here. Look at this 3p here. Now, how many electrons do you have here? Only 1. That means out of these 3, I only use 1. I only have 1 electron, right? These 2 are not used, so I will just put 1 here. So you go to calculate it together. 1 plus 1, 2 plus 3, 5 plus 1, 6 plus 1, 7. So we have 7 orbitals. 7 what? Orbitals. So how many orbitals are contained in an atom with atomic number 13? The answer is 7. So these are things you need to pay close attention to. You need to understand this concept very well. I'll be posting more of this video here. But if you want to join my class, I have done videos on this one here so I understand better. Before you join my class, send me a message, make payment, then join class. We have done question 1 to question 4. We still have 3 more questions because I want to solve 7 questions. So now let's solve the remaining one. Now look at what question 5 and question 6. An atom S consists of 6 protons, 6 electrons, and 7 neutrons. Which of the following representation of atom is correct? So if you check it very well, this question is very, very easy. Now, if you check it very well, here we have A and Z according to the structure of atom. A is what? Is the mass number. Mass what number. And here is what? Is the atomic number. Here is what is the atomic number. Atomic number is also the same time as proton number. Right there. The numbers of proton in an atom is not what as the atomic number. Now, mass number, what you want to know there, mass number, which is what A is equal to what? Proton plus what? Neutron. Proton plus what? Neutron. So if you check it very well, my Z, if you check it very well, now this is an atom consists of atom S consists of 6 protons. That is proton equals to what? Is equals to 6, right? Electron is equal to what? 6, and neutron is equal to what? 6. So we have proton 6, electron 6, neutron and 6. So now let's write the atomic symbol. First, we want to look at here. We want to get our what? Let's get our what? Our A. Our A is what? Proton plus neutron. So my A here, I can just say, let me write it here. My A is equals to what? My proton is what? Is 6 plus my plus neutron. My neutron is what? Is 6. Okay, neutron is 7. Neutron is 7, right? My neutron is what? 7. So 6 plus 7 is what? Is 13. Then, so my A is what? Is 13. Then my Z, which is the proton here. Proton, which is proton. What is proton? Proton is 6. So the atomic symbol, right, is now going to be X. My A is what? Is 13. Then my Z is 6. It's okay. So which one is that the answer? The answer is what? The answer is what? Is A. This is that the answer is A. You can see how easy it is. If once you understand the concept very well, you find that this is a very, very easy. So look at this guy here. Look at our question 6. Look at our question 6. Look at question 6 here. They say that the numbers of unpaired electrons in an atom of elements 8 is. How many unpaired electrons do you have here? Now, how do you get the numbers of unpaired electrons in this question? Now, to get the numbers of unpaired electrons in this question, you have to write the electronic configuration. Write the electronic configuration. And electronic configuration of oxygen is what? Remember, I gave you something that whenever I want to write electronic configuration of an atom, any atom at all, as far as JAMB, WAEC, NECO, O-level, you only need this guy here: 1x, 2x, 2p, 3x, 3p, 4x, 3d. These are the things you need. So here we have 8. The atomic number is 8. Remember, in a neutral atom, the atomic number and the electron number are equal. In a neutral atom, atomic number and electron number are equal. So if let's see 8 electrons here. The oxygen now, they're going to be what? So let's take first one here. We have 1x2, right? Out of the 8. The next one is what? 2x2. Now out of 8, I've used 4. How many left under 4? You now have what? 2p what? 4. This is that 2p4. Now they are talking about the unpaired electron. You are going to use the orbital p. p orbital. Remember, p orbital, like what I explained earlier in some of the other questions, p orbital only have three what uh, suborbitals. How many electrons do you have here? You have 4. Now, when you are filling electrons, which will guide the filling of electrons into degenerate orbitals? The rules that guide the filling of electrons into degenerate orbitals, like orbitals with the same energy level, that's called degenerates. The rules that guide this called the Ohm's rule. And Ohm's rule state that when you are filling electrons into degenerate orbitals, electron must spin up before spinning down. So here I want to fill 4 electrons in here. So they must not first spin up. So you have 1, 2, 3, and 4. You see that? So here we can say 1 paired, 2 unpaired. So here we have 2 unpaired electrons. They're asking how many unpaired electrons do we have? Unpaired electrons. So it's 2. The answer is what is what A. Now we have to end our class here. We have to end our class here. More of this video will come your way. So please follow and subscribe to this YouTube channel. Now, if you want to join our private class, right? The class is 29,000 for the first 100 persons. Our class has started from November to December. So these are the first 3 months. We have to cover the entire JAMB syllabus. So by January, when people will be getting serious, we have already covered the JAMB syllabus once. That is going to be the advantage. However, we still have our general group where we learn only once. Probably if I want to do video like this, free video like this, right? You can just join the class. So to join the class, look like message that I want to join the class. If you want to join the private class, send me message directly that you want to join the private class and make your payment to join the private class. You see, after we are seeing in October, right? October, November, December in 2025, you have to cover the entire general syllabus. So by 2026, January, February, March, April, you have to cover this content. There is going to be an added advantage for you. So if you want to be part of the class, send a message. But if you want to be part of the free class, look like Mr. I want to be part of the what free class. Please specify that I want to be part of the free class. Now, but you want to be part of the private class, send me a message directly that I want to be part of the private class. And you'll be added. You make your payment and you'll be added. Just thanks for watching. See you in my next video.